Oh, hello, good afternoon, everyone. Okay, so welcome to Introduction to Computer Science. Can you hear me well, Matthew? Can you hear me well?
Yes, sir.
Okay. So today we'll discuss about uh, uh, graphical user interface and then debugging and unit testing. Okay. So the links to the material already in Lentera, so you can start to follow. So okay, can you see my screen? Yes. So for for our graphical user interface, we can use PySimpleGUI. PySimpleGUI. Okay. So if you want to install, so you just search in Google. Okay, and then uh, this is the command to install. I hope you already installed. Last week I already asked you. Okay, and then uh, once you install that, okay, so you can go to the home page of that PySimpleGUI, which is in GitHub. Okay, and you can see a lot of examples in this website. You can see a lot of examples and uh, how to use. Okay, and in the first example, you can just copy and paste this, right? And then you open, say, Jupyter Notebook, okay, Python 3, okay, or you can open a spider, okay, with a new file and then copy and paste, right? So, and when you run, you will have a GUI asking what is your name, right? So, say my name is Cardi, click OK. That's it. So, the result is in this scene. Can you see it? Okay. Hello, Cardi. Thanks for trying. Yeah? So, this will give you the basic. Yeah? So, first, okay, in line 8 here, okay, is the import. Okay, and then when you want to create a layout, okay, that layout is basically a list, right? It's very simple list. So uh, and then after you create that layout, you create the window. Okay, so SG window here is the, so this is the title that you want to set. You can, any string there you can just change. Okay, and that layout is the one that you already defined, that layout here. Okay, and then what happens is, if you don't create any loop, so you will have event values read. That means this is actually the event loop that read. Okay, every time it will move here and then it will read. Okay, and once you read that value of this window, okay, and then uh, print the hello, right? And then what is the value 0? That is the actual things that come from these values that read. So Windows read will return two things. Okay? One is event, the other one is the values. Okay? So these are dictionaries. Okay? So when you get the value 0, that means the value of in dictionary number 0. When you finish, you can just close it. Okay? So is there any question about this? Can you run it? Now, you want to be more uh, a little bit more complex, okay, again in the same website of the PySimpleGUI, okay, we can just copy the second example here, right? And then you copy, and then you create new one. Okay, what's going on? So first you import the PySimpleGUI, right? And then you create the layout, okay? And again you create the window. After that, okay, now we have an interaction. So if you want to have interaction with that, so you need to create a while loop. Yeah, without the while loop, when you finish, it will stop. Right? With the while loop, it will stay there, okay, forever practically until you say stop. Okay, so in that case, you need to say when it will stop. So this code here is telling, okay, if the event is quit, okay, or the event is window close, then break. That break is break of the while loop. Okay, that means it will go to window close here. Is it clear? Okay. Otherwise, okay, so otherwise mean this line will be done. Okay. So now look at the layout. Okay. Here is the text, and then we have the input. Yeah. So this is text is just text. It's a label, right? So this is exactly similar to HTML label. Okay. And then this input is just a box, input box. Okay. Again, we have another text that you specify the size. Okay. And then you have two buttons. Yeah. Button OK and button quit. So when you run this, you see exactly that layout that you have. Is it clear? Okay. So you can change. Okay. You can change all of this. You can change on your own. And what is the how you will call the value, okay, or the event of this is based on the key. You see that? Okay. That key is practically just name. Okay. So that you can distinguish one from the other. One element from the other. Okay. So here, Windows output, that means output is this key. Yeah. Can you see? The same name, right? That means Windows get this this text, okay, and then update of the value of the input. So this is the input. Can you see that? Right? And then it will say thank you for trying something. So we try that. So what's your name? Oh, Billy. Okay, my name is Bill, for example. And then it will there. Can you see? So it will get the input, yeah, and then it will send us output, okay, in the Windows itself. So you can go in, you can go out. Any question? Is it run? Did you try? Run, right? So yeah, the explanation is rather clear. So, so there are many example in this website that you can also try on your own, right? So say example here, you can create calculator, for example, right? Okay. And you can also create games and so on. So, and you can change everything based on what you want to do, yeah? So, and then explain how to install and so on. So, okay. Yes, go. is in GitHub, PySimpleGUI. No, no. You go to PySimpleGUI install. Okay. And then if you go there, right? Can you see that? And then you go to the home page. Okay. So there. This is the basic way. Okay. So you will go here, right? So yes. So the remaining is just oh, see, you can even play a chess game, right? So all you need to do is just copy and paste. Suddenly you create a chess game in your Python. Okay, this is Minesweeper. Oh, you can also create Minesweeper game. Again, all you need to do is just copy and paste. Oh, even the, what is this? Card game, you can even play that. Just get the sample game and then copy and paste, you can run it. Cool, right? Oh, so what do you think? So you can make it for your project. Oh, if you have any questions, so go ahead.
Yes, sir.
Matthew.
Do we need to use PySimpleGUI or we can use others?
Oh, of course you can use others. So the default of Python is tkinter.
Oh, okay, sir. Thank you, sir.
Yes, yes. So you can use many. You can use Qt, for example, Qt5 and so on. So I just give you this, which I believe to be the simplest among all. Okay, because all their layout, what you need to do is just copy and paste of those layout, and then you just change that based on your own need. Okay. So next, I'll go deeper. Okay. So in my website, I have Premagic games, right? So again, I will share my screen. So I have a Premagic game that we discussed last meeting. Okay, about natural matrix and so on. Okay. So in here, if you look at this code, okay, what I'm doing is actually exactly the same as the layout, right? But instead of putting that layout directly in the code, okay, I just create the layout into string. Okay, so if you copy and paste this code, right? So I put here. See, the result is not a code. This is just the layout itself, right? This is just the layout, but I put it into string. Can you see that? Okay. Why? Because apparently Python can run any string, yeah, using the word eval. Yeah? So go to eval Python. Okay. See, this is the method eval will pass the expression and then run as if that is your code. For example, eval number plus number, number is 9, it will become 81. Right? As if this is real code. Okay. So the syntax is just the expression, so any string expression, okay, and the others is just global value. So for example, yeah, x is 1, and then you said if x plus 1, what will happen? It will become 2, right? Now the same thing here, okay. So when we have this code, when you do evaluation of this code, right, then it will run as if this is a Python code. Okay, so with that, I don't need to create the layout. So the layout is just that string. Okay, the layout is just that string. Okay, but one thing you need to do is in here you set eval of that layout. Can you see that or not? Yeah. When you want to set layout, instead of layout, you do evaluation of that layout so that it will become a code. Yeah, the string, you change it into code first before you insert when you run. Okay? Okay. After that, you can just print this so that you will see. Okay. So let me copy and paste this. Okay. So, oh, what happened? SG is not defined. Okay. So let's define that. Okay, let's define SG. Now, when you run that, you will see this layout. Yeah. Still in name. Okay, so the name is E1, E2, E3, and so on. Okay, and this is R1. It's just the name that we created. See, this one. The name is E1, right? The name is E2. This is the size and the background color. Can you see it? So this represents this, the layout, but that we generate over string. So this is a little bit more complex. Why? Why we want to do this? Because you want to create matrix of any size, isn't it? Right? So it can be 3 by 3, can be 4 by 4, can be 5 by 5. So in that case, if you do without this string, yeah, so if you want to create matrix 5 by 5, what you will do? Oh, you will recode again, right? Oh, that's crazy. You will recode this input text 5 times, correct? Oh, that's crazy. How about if 10 by 10? Again, you will recode 10 by 10. Okay. So in here, for example, if I have 10 by 10, okay, right? So n is n3. So I will put 10 here. Let me close this. Right? All you need to do is run. Oh, suddenly I got 10 by 10 without changing any code. Isn't that cool? Right? Without this, what will happen? If you want to do 10 by 10, you need to code again one by one. Okay? So the important thing in programming is to reuse. Okay? The same code, if possible, is the computer that do all this repetition, not you. Okay? That's very important lesson in programming. Don't repeat yourself. Okay? Reuse. Okay. Without that string, what happens if you want to do this 10 by 10? Okay, what you will do is You see? I will close this first. Okay. Yeah. This is 10 by 10. See? The code is very long like this. Okay. Which, if you do manually, it's boring, right? Right? See, very long code. Let's computer do that code for you. Okay, the computer can code for you. So let's computer code. Is it clear or not? The purpose. So all you need to do is to create that string of the code. Okay? So what do you think? Okay? So of course, the second version here, okay, that is, in the first version is just name, right? So it doesn't do anything. There's no input. Yeah? So in the second version, okay, we change the layout, okay, except the event, the same. Okay. So to accept the input, okay, to accept the input, you need to make enable event true. Okay. To accept the input, you need to make the enable event true. Okay. And then we add the key name so that each element of the graphical user interface will be unique, right? And then we give a name. This is the agreement to make the name. So again, you can just copy and paste here, version 2. Okay. Now I copy and paste. Now I put version 2. Yeah. So again, if I put 5 or make it 3 now, you can see. Okay. So again, I will generate the code, right? And you see in the code, I already have enable event true. Can you see that? Yeah. That means enable event true means it can accept the input. Okay. Without that, it cannot accept the input. Okay. And then what we will do? Just copy and paste the second version of the game. Okay. Now you get the actual code. Oh, what happened? Math is not. Okay, I need to define math. So import. Oh, is premagic not defined? Okay, I need to define is premagic. The code is premagic is already here, so you just copy. Okay, so I put it on top of this. So I will insert here. Insert. And then I can start to do this. Oh, there. Right, so it will create automatically a random numbers. Okay. Oh, now become a game. So that means this is 33 and 27. So now you need to change anything in yellow so that the sum of rows is equal to the sum of columns. Okay. In the least possible move, that is the game. Simple, right? Okay. So So in the list, but for example, I change this to 3. What happened? Okay. So is it correct? So if it, so 19 more steps. Yeah? If I change this to 15, so, oh, now become 17 more steps and so on. So there is a limit number of steps that you can change. Okay. So of course, this is just a game. So if you look at the code here, okay, this is just the color, and you generate the board. Okay, again, you create the windows, and to generate the windows, I evaluate the layout. Okay, all these are just parameters. So where's the location and so on, right? And then I generate random matrix. Okay, from that random matrix, I inputted that value. So how you input using Windows for each TXT E, right? Because I have a index of that, so each one by one I input. Yeah. How do you input one by one? Using this for loop. Okay. So using this for loop, I will know the row, I will know the columns. Okay, and then I will update. Yeah, I will update that matrix A here also, so that the one that you show is exactly the same as internally we have a matrix A. Okay, and then we get the return value of is pre-magic of 8 a while ago, yeah, inside, and we get the sum all, right? And then what is this? This is just to get the sum of row and the sum of column, yeah, and the sum of total, right? And then the real interaction come from the while loop here. Okay, in the beginning you just read the value. Okay, if it is closed, then break. Okay, now if the event is the first how many 4 elements is txte, okay, I don't care about the index name, right? Then it will get the value, right, and then split that, and then check, okay, update the matrix, okay, and then check whether it is already pre-matched. Okay? So by calculating all the sum of row and sum of columns, and then how many times it will number of change of the update of the user playing, right? How many times it click. Okay. So if the return value is correct, so this read file meaning that it's already pre-matched, okay, and then it will say, oh, you won how many times. Okay. Okay. So if the number of count, how many steps is larger than the maximum count, then you said you lost. Right. So if you want to know more, you just open this comment so that you can see what is the event, what is the value. You can try. So give me comment. So in the chat, I put another website. This is like the cookbook of the PySimpleGUI that you can also open. Okay. So there are many examples, yeah, in this website that you can also just copy and paste practically. Right? So many recipes that you just copy and paste. Okay. So one of the example there is all elements. So in this example, you can also create menu, right? And then you can create certain columns. I will run this so that you can see. There. Yes. Okay, there is a menu. Can you see? So it's a full website, right? With the menu. Yeah. You can see the menu here. So all you need to do is just to put file, open, save, exit, yeah, right? And then this is the first column. So the column is the column 1. We'll have a spin box, right? And here, this is the column. Okay, and then the layout. First part is the menu, right? And then you can see this is the label here, text. Okay, you have also frame. You see, and then inside the frame you have checkbox, you have a radio button. Yeah, you can also have a combo, right? You can also have slider. Oh, see slider, right? And then well, you can also the submit, and you can also browse your file. Oh, automatically you can browse inside your file. Yeah. So yeah, that's it. So if you cancel, so remove, so you will have a pop-up, another window. Okay. So up to here, is there any question? So with that, I can say that our GUI lesson is finished. So you can make GUI on your own, yeah, for your own project. Right? I think some of you already did, right? Okay. Okay. Any question? No question. Wow, very good. I love the students. Okay, so let's go to the next lesson, which is about debugging, yeah, and unit tests. So in your project, one of the requirements is to create automatic testing, right? Why? Why you need to do automatic testing? Do you remember? During software engineering, okay? Yeah, because you need to do refactoring, right? If you want to change your code, you do unit testing, okay? Before you change, you do unit testing so that all pass the test. After that, you change, right? And then you do unit testing again. Oh, it did not pass, meaning the last change that you make is the one that creates the problem, right? If you do not have unit testing and then you change, you don't know. So if later on you create an error, you don't know which one is making the error, right? So with unit test, okay, before creating any change in your code, that code is already working, okay, then you do unit test. Okay, must pass all, okay, and then you change, right? And then you test again. So unit test is very important part of programming. Is it clear or not? Okay, so let me. So if you go to Lentera, okay, debugging, refactoring, unit test. Okay. So if we go to the website in Revoledo, okay, in this tutorial, we learn about debugging in Spider. Okay. So several things we will discuss. One is catching error, okay, and then debugging itself, right, and then refactoring, and finally unit test. Okay. So let's start. So error in any programming, yeah, is very common. So there are many type of error. Okay, so the simplest error is called syntax error. Oh, I haven't shared my screen. Okay. Can you see? Okay, the simplest error is called syntax error, right? This is something that the compiler or the interpreter, in this case your Spider or your Jupyter, okay, already know. So you create a, mistype, okay? So in this case, very easy. So if you get this kind of error, you just need to change the code, yeah, to make it correct. Okay, and in fact, Jupyter will tell you, right? Okay, oh, there is a error in what line? So you can just point it, not exactly that line, probably a little bit up, a little bit down. Okay, that is the one that around that area is the one that make the error. Okay, so and then there is also possibility division error. Yeah, if you divide by 0, right? So it is create division by 0 error. So of course, computer will complain, yeah, because anything divided by 0 is error, yeah. And if some of your variable or your function is undefined, again you get name error, or your class is not defined, like a while ago, you get name error, yeah. Or maybe if you have different data type, okay, supposed to be string, but you put it as integer, you get what is called type error. Yeah? So one simple way to catch the error, so that it will not always complain to you, okay, is to use this syntax. Yeah? You should say try, okay, and then you have a statement, okay, except, meaning the statement after the except, okay, will run if there is an error, okay, and then else it will be run if there is no exception. Okay, finally is the statement that will be run regardless you have error or not. You get it? Okay, so example here, okay, say d equal 1, okay, abc equal d. Okay, let's try. I try here. I create a new Python notebook. Okay, and I will say, look, d is actually only 2 elements, right? A1 and ABC, but I said I have 3 elements in d. Okay. What happened? Oh, you have value error. Of course, there is an error. We created that error. Yeah. So not enough value to unpack. Expected 3, you got only 2. Right? Because element is only 2, but you said 3. Okay, so there is a value error. So, so that Python will not complain, right? So you do it this way. Try. Okay. So you do it this way. Try ABC. Okay. This is clearly wrong, right? But it will not complain. So it will say that not enough value, the same, but no error. Can you see the difference? Okay. What's the meaning of this? If you have error, your program stop. All right? If you have error, your program stop. Below that code, below that error will not be run, right? But using this, okay, using try, your program never stop. It still run. Okay? Okay? But it will still say the same error. Nice? Is it clear or not? Yes, yes, go. Did you try? Did you try? Try it first, then you will see. Try this one with the error and try without the error. Okay, and then what's the difference? Okay. Now, look, if you still want, okay, if you still want, if there's an error, you want to stop it with the try and accept, but you still want to stop it, you add raise. Okay, so after this E, again, you add raise. Okay. Oh, it will go back to the original. Okay, it will stop. So the keyword here, raise, okay, if there is an error, raise that error. Sometimes it's useful. So if not, you just comment it. Right? So is it clear now? Can it? You are still getting the same. You want to share your screen. Go. You share your screen, Kenneth, so that I can help you. Okay, one by one, one by one. So without the try, okay, comment that. Okay, and then you run, you get an error, right? And then now you uncomment that, but number 10 you need to comment, right? Of course, right? Because exactly the same, right? Number 10. No, D is correct. 10. Only that one. You comment. Okay, and then you run. Okay, but it doesn't generate error. It run, it doesn't generate error. So if you have many code below that, it will still run because it doesn't generate. It just print. If you don't want to print, you just instead of print E, you just put pass. It will not even print your error, right? So instead of print E, okay, you comment that print E, okay, and then name it pass. Below that, pass. PI, yes. Then you run. See, no error. Okay, clear, right? Any question? So, Stephen, Karin, can you do it? Just copy and paste and try. Okay, so let's try this divide. Okay, so the next one, let's try this divide. Okay, of course, if you look at this code, okay, I use all, right? I use try, except, else, and finally. Okay, so let's do that. Copy here. Okay, so there. That's the code, nothing else, because I just defined. To use that, so say I want to divide, okay, 1 divided by 2. Oh, no error, result is 0.5. Where did it come from? So first it will go here, right? Okay, 1, x is 1, y is 2, yeah? So z, we try, okay, 1 divided by 2, there's no error, right? So it will say this line is printed with no error. Okay? Go to the else. Okay? This exception will only be called when there is an error of division by 0. Okay? So, and then this line, okay, will always be called regardless whether there is error or not. Okay, so let's try that. So 1 divided by 0, what will happen? Oh, okay. It will not print this one. It will only go here and then go to the finally. Yeah, if z is not defined, it's error. That's why you need to define it. Z is equal 0 here, right? You need to define that. Okay, so if there is an error, if z is not defined, then you need to define it, right? In the exception. That is the purpose of exception. Okay, so yes, I know there is an error, and then how you will correct it. In this case, I correct it as z equals 0. Or you don't want to correct it, you just raise as error. How? That means you do raise. Okay, it's up to you to decide what you are going to do with that error. Question? Is it clear? Really? Huh? See ya. Okay. So this is finished, yeah? The spider I will just close. Oh, no, I will use spider later. Anyway, so debugging. What is debugging? Okay. You know, to find bug. Okay. In the old days, okay, computer is like a machine, not just machine like this small. Okay, it's a machine inside the room. Okay, so there are many bugs, real bug, huh? Okay, insect. Okay, that cause the computer to become broken. So at that time, in 1940s, they really need to find the bug that caused the computer broken. Yeah. So that's the history why we name it debugging. Okay. Computer programmer is very proud of their work. Okay. They don't want to. Oh, your program have error. They will feel hurt. Their pride is feel hurt. So no, I will debug it. so okay, finding the bug, not error. Okay. So that is just to euphemism. Okay, so how do you debug? Okay, basically debugging means finding where and why the error happened. Yeah. So how do you debug? The simplest way without any knowledge. Okay, if you don't know anything, you don't have any tool, you just use a notepad, okay, to run that Python. Possible, right? Okay, so say using the command line, you can run that Python. So the simplest way is to print the value. Any variable that you want to know what is the value, you just print. That's it. As simple as that. Right? So without any IDE, just print the value of the variables, yeah? Or the return value of the function. Right? And then, is it the one that you want? If not, so then you find where. So every time, okay, for example, you run the Python inside your server. Yeah, that server is in the US or in Japan, for example. Okay, and it's black and white, right? Oh, I will debug. I don't have Spider. I don't have tools to do that. Okay, no problem. Just print the value, right? Okay. So yes, debugging can be very frustrating experience for the new coder. So you can code in a few minutes, okay, but debugging can take hours and even days. Okay. In fact, you can check if programmer is experienced or not. How do you know? By the time of the debugging, not the coding. Coding is always fast. It's just typing, right? Sometimes you just copy and paste, isn't it? Right? It is the debugging time that qualify you as good programmer or bad programmer or just beginners. Okay? Debugging time. Okay, so when you see the time, a more experienced programmer, of course, will have less in debugging. Okay, so when your compiler still give you error message, I said you should be happy. Why? Because computer can help you to find the error. Yeah. Sometimes when your program runs smoothly without error and then produce wrong result, that the result is not what you expect. This is called logical error. This is the hardest part to debug because there is nothing. You run, there is no problem. But this is not what you expect. Then you need to find where is the error come from. Oh, that's very hard. Okay, that can take days to, hours to days to finish. Okay? When the computer tell you this is the error, be happy. Okay, so one way to do, okay, I will run the Spider again. Can you open your Spider? Okay, Spider or PyCharm if you use PyCharm, or you use probably, if you're like me, I'm using also code, yeah, VC code. Where is my VC code? Oh, there, right? Visual Studio Code. Yeah? This is also another IDE that you can also use. Yeah? So if you use Spider, so I'm just discussing Spider here. Okay, you can debug easily. Okay, how? You set the breakpoint. Okay, so when you have an error, okay, and then you just set a breakpoint. Say I have a, this is last week, right? We talk about calculating the sum of row, sum of each column, sum of total. Remember? Okay, so I want to do debugging. Okay, so say in the second loop here, can you see if I press my mouse here, you will see the red dot. You click that red dot, will be there. That is called breakpoint. Okay, so if you run debug, okay, it will stop there. Okay, when you stop there, what you will do, you check the variable explorer. Okay, then you will see all the values of the variables that is in the memory. So without this, what you will do, you will print. Okay, print A, print I, print MC, right? You will print one by one. Okay, but without IDE, you need to print. But with IDE, okay, you just stop there. It will run, and then you will know at this point of time, okay, these are the value. Okay, and then when you want to run one line of code, you just click this part, run current line. It will go to the next line. Okay, and then you see SJ here, 0, right? And then if I run again, it will go back up. And then SJ is now become 1. Can you see that? Right? And then if I run again, okay, and then run again, SJ now become 3. Why? Because 1 plus 2. and so on. So you can see how the program works, okay, by debugging this. Okay. So this is very important tools. Okay. Without this, you will not know how it works, right? So, and then you just print one by one, and then you need to look where it come from. Why? Okay. But with this, you just stop there. Oh, okay, this is not what I want. Then maybe something wrong here or there, you can guess. So this will not correct your error, but at least give you the what is inside the program. So, any comment, any feedback about this? Yeah. So you run debugger, okay, and then you can step in. This is one step, right? So this is one line step, okay, and then what is this? This is step into again up to the next breakpoint. So you can create another breakpoint here. See, okay. So I run this, not this one, not one step. I run up, go out here. This will go out of the function. Yeah, if this is a function, it will go out of the function. Or I can run up to the next. Yeah, execute until the next breakpoint here. Oh, see, I will go to the next breakpoint. Okay, I don't want to look too much here. Okay, I will already know, so I go to the next one. So just click again here, the next breakpoint, and then run it. Okay, the next breakpoint is still here, right? So and then close that breakpoint and then run. Oh, it will go to the next breakpoint. Okay, use this tool. Okay, and you see the value change, huh? Every time you run. So what do you think? Is it useful or not? Yeah. If you want to stop debugging, you just stop this one. Okay. So you stop debugging. Of course, it's just stop. Okay. If you run here, this means just run without debugging. See? Get the result. Okay. When you debug, you need to debug here. Second time, debug. Okay. That will go to the breakpoint. Yeah, you set the breakpoint first. Where to stop. Then you can run one by one to check the loop, the value inside. So what do you think? Is this useful or not? Huh? Yes, yeah. What happened? Next. Okay. Oh, what happened to this? Why we have refactoring? Okay. So, can you see my screen? Okay, refactoring. During the software engineering topic last time, we discussed refactoring. Right? What is refactoring? Modifying your code. Yeah. Modifying your code without changing the input and output. Okay. The external behavior of your code after refactoring will be exactly the same, okay, but the internal behavior is improved. Okay, what is the meaning improved? Probably you make it faster, right? Okay, the most important part actually to make your code easier to read. Instead of X, Y, Z, you probably keep a name, their full name, right? So that easier to understand. Okay, so you probably want to change the data structure inside, right? Oh, my code is already working, but I want to change data structure from tree to become network, for example, from list to become dictionary. Why not, right? Or you probably want to change the algorithm, okay, to make it faster. Okay, the input is the same, the output is the same, okay, but the result is faster. Or maybe consume less memory. Okay? Or you make a simple design. Okay? Instead of one very long function, right? You probably divide it into many functions, short, very short, so that you can reuse that same function again and again instead of typing it. Okay? Or you can improve the tolerance of the code. Yeah? Maybe you want to abstract it, right? Yeah? So that can be reused for next other project, not just for this project, but for other project. Or maybe you want to add documentation. Okay? So again, there are many reasons to refactor. Yeah? These are a few reasons. Yeah? So what do you do to refactor, right? You change the name of the variable, maybe the method, the module, the class, right? And then you do this change based on certain coding standard yet that you created. Okay, the name must be camel, yeah, up and down, capital letter, lower letter, or use underscore. It's up to you to decide what is your coding standard. Or you use system metaphor. For example, banking. Of course, you will use the banking metaphor, right? Financial name of the bank. Okay? The same program you use for cooking, you probably name it as the cooking style. Okay? So this is to make easier to understand for the people who read. Yeah? Say you change the name so that that is not useful into something that is meaningful. Okay? Or you can have a very long parameter, the list, and then you make it simple into a simple list. Yeah? Or you have very long if elif, very long, and then you can make it simple one with the hierarchical. Yeah. Or you can change the loop into list comprehension so that easier to read. Yeah? Okay. So many others. So these are, you can read by yourself. These are the possible way to do refactoring. Okay. You remove duplicate code. Yeah? So if you have a global constant, okay, that will create spaghetti code because the global constant very easy to code, okay, but very difficult to debug. Okay, so in that case, you put it into parameters of the function. Yeah. One way to improve the code is to remove the global variables. Okay, so in this example, can you see? These are global variables. The variable that can be seen by all functions. Okay, so probably this one I will put it into file, for example, instead of global variable like this. Okay, so again, everything that very long, difficult to understand, you break it into smaller. Okay, that kind of breaking the code without changing the behavior is called refactoring. Clear? Okay. So what is the requirement of refactoring? You can only refactor if you have a unit test ready. Without unit test ready, you cannot refactor. Okay. Okay. The existence of the unit test is the guarantor that the code will behave externally the same. Okay. So how do you refactor? Again, first you need to run all the unit tests. Yeah? Pass all the tests without error. Okay? If you want to add unit tests, you can add. Okay? After that, you refactor to change the understanding. Yeah? And then you run the unit test again. Every time you change, you run the unit test. Must pass all. Okay? The same thing. If you add, say you want to add more unit tests again, and then you modify the code, okay, until pass all the tests. Okay, so the unit test will be run again and again. So this is called test-driven development. The idea is to create the test before you develop your own code. Okay, before you make the code, you create the test first. After you finish creating the test code, automatic testing, Then you start to create the function of the class just to pass your own test. Is it clear? Okay, so this is exactly what the agile technique last time that we discussed. Yeah. So the protocol is to do unit tests before you code, yeah, and after you code. So all the code must pass all the unit tests. Okay, using that protocol, you can modify, you can refactor your code mercilessly. Okay, you can modify whatever you want, no problem. Okay, why? Because you have unit tests. Okay, so this is because unit test is basically the automatic testing. Okay, so very useful technique. Okay, and especially if you work in a team rather than by yourself, right? So each developer will do exactly the same protocol above. Okay, whoever break the code must responsible to fix it in a team, right? Or else, okay, his code or her code will be rejected to be included in the committed code. Clear? Okay, so let's go to the last part here, which is unit test itself, right? So unit test is useful to test your function or your class, okay? Okay, why you do that? Because you need to do refactoring, you need to do debugging, maybe you want to add feature, right? Or you want to review your code. So unit test is the requirement, refactoring, debugging, and all of this, yeah? So by spending a little more time defining your unit test, you actually save a lot of time in debugging unnecessary error. Okay, look like, why should I make the test first? Look, yes, I need to code it. It's double code, right? I need to code the main code, and then I need to code again the unit test, right? It look like double work. It's not. Okay, why? Because with this you can be confident to change the main code. Clear? Okay. So how do you make unit test? Yeah, in Python you just import unit test. Okay. So import the unit test, and then you create a class. Okay, the class of test case with this inherit exactly like this. The name is up to you. This one. This is I give name my test cases. So, but the class name is up to you. But the inheritance, okay, the parent must be unit test dot test case. Clear? Okay, and then you build the test case of the correct value. Okay, for example, I set up any value, and then don't forget to give name, yeah, test, yeah, and then test self, right? Because this is a class, so this is the function inside the class, so it's a method. Okay, so for example, I give one test. Okay, and then what you will do, this is the test, and then at the end you will say self assert equal. Okay, this is your input. This is the answer from the test, and this is the answer that you already gave. The correct answer that you supposed to be. This is the answer. Yeah, of course, right? A B C. This is supposed to be A B C D, right? So you already know the answer. Then you said assert equal. If the solution is supposed to be false, then you said assert false. Clear or not? This is the logic. Yeah, true, false last time. Huh? Okay, assert true, assert false, or assert equal. So these are the main. And then when you want to run, you just copy and paste exactly this one. Okay, when you run this, okay, you will see run 3 tests. Okay, okay means okay. That means you pass your unit test. Is it clear or not? Or you want to try? Just copy and paste this one. Okay, and say I create here. Oh, okay, fine. Right. This means I have 3 tests. Okay, let's try if this is not correct. Okay, make it not correct. So I have E in here. So it should not pass, right? Because this is A, B, C, D. Why the answer is E? Your answer is incorrect. So I run this. Oh, fail. Yeah, you see, the risk is different. Yeah, so there is an extra E. It will complain. Yeah, so of course you need to test so that all 100% correct. Yeah? Okay, when you see okay here, run 3 tests, you are happy. Automatic test. Okay, the same thing in your project. This is a must. Yeah, you need to have this. So in the next presentation, okay, you create a unit test. Okay, and then you show that your code is all working. Yeah, with 100% no error. Okay, let's try to define factorial. Okay, this is the factorial. Okay, can you? Okay, this is the factorial. Define. Right. So when you define the factorial, it's nothing. Okay. So initially, probably you want to define factorial without all of this, right? See, the factorial definition is just like this, right? Initially. Right. Okay. And then what you will do, you test. Okay. You test. So you need to test, you need to tell the correct case. Yeah. Factorial of 1 is 1, factorial of 2 is 2, right? Factorial of 3 is 6, factorial of 4 is 24, yeah? Factorial of 5 is 120. You know this is the correct case. Okay? And then what you will do, say, don't forget that the first name must be test. Okay? And then you can put any name here. So test easy correct factorial. So the input, okay, that is the correct case here, right? So for each input and output, this is the input, the result must be the same as output, right? Okay, and then floating value is not allowed, so okay, you can test, okay, if it is correct or not. So, and then 0 is not defined as 1, right? Factorial of 0 is defined as 1, so you should say this one. So you create the test first, okay, and then negative is not defined, so it must be out of range, right? And then factorial can handle big input and but not larger than 2,500. Oh, you know the maximum value, then you can test above that maximum value. Okay. You deliberately make it error, okay, and then it will show out of range error. Huh? And then factorial can handle big input beyond set of maximum recursion limit. So this is the test that you want to create. Yeah? So out of range, not integer, is just a class here that we define. Okay, so let's copy this, import. Okay, up to here, it will not pass. Yeah? I run this. Okay, and then what I will do is I run this one. Again, this is just copy and paste, right? So I run this one. Control V. Oh, error, right? It will not pass. Why? Oh, there are many errors. Yeah, error negative, floating is fail. Yeah? All of this fail. Yeah, why? Because my factorial is too simple. Yeah, it doesn't pass the error. Okay, in that case, I need to modify the factorial. Yeah, to include if it is not integer, if it is between, if not between 0 to 2500, right? What is the purpose? Again, to pass your test. So the test is the specification. Can you see that now? Okay. Based on what the user requirement, that is the one that you put into the test. Very clear. Yeah. So when you put this all, okay, into that factorial, and then you run the test. Run this, just run this one. Oh, it ran 9 tests and all no problem. Yeah, happy. Yeah. After this, you can modify whatever you want in your code, okay, and then you run the test. Okay. If this is already passed the test and then you change something and it create error, you know what make the error, the last change that you make. So with that, you save a lot of time. Every time you change, you run the test. Okay, so what do you think? Any question?
Sir,
Yes, yes.
if mine is machine learning, right? So the prediction is not 100% accurate. So for the unit test, can I just like check for whether that my software can produce output and take input and many others, but not the result of the prediction?
Okay, what is the prediction that you have right now? For example, how many percent?
Currently is quite high, 98,
Okay,
99.
98. Okay, 99. Okay, so you can just get that prediction. It is 99. Okay, and then you assert, right, that the value must be larger than that, right? So if large,
Uh,
okay, right? After you modify, suddenly less than that, so something wrong with your modification, isn't it?
okay, so I need to like create a couple of unit tests and check whether the prediction is above 99% or not.
This is one example of very simple test, right? But if you want to go to the detail, you can go for each part of their program, you can do a unit test.
Oh, okay, sir. Thank you, sir.
Huh? So for example, your current value is already 98%, right? After you modify, become 97, so something wrong with your modification, correct? So then you say, okay, assert value must be larger than the current value, which is 98, right? Correct. Oh. So that is one test, right? But of course, you need to make it so that not just accuracy, right? So anything else that you want to test, you can also test. Yeah. So for example, what if the user actually input it wrong with certain, for example, it's supposed to be integer, but the user input it as string, for example. You need to test all possible error that may happen. You need to put that so that the system is robust. Okay, what user is the king. Okay, they are our customer, so they never do wrong thing, right? Okay, so in that case, your system must be robust against all their error. Okay, don't ever blame your customer. Okay, because they are your king, right? Oh, customer is the king, okay? So in that case, your system is the one that you're supposed to adjust yourself, supposed to adjust your code, eh, to accept that problem, and then you just give warning, gracefully, right? Okay? Don't blame, oh, because your the user is wrong. Very funny. No, okay? Your code is the one that is wrong because user never do wrong, they are the king. Okay, your customer. Okay. So, any comment? Darin, Stephen, you need to make unit tests in your code. Okay, okay, at least 3 tests. Very minimum, 3 tests. Very minimum, right? The same with your Matthew, yeah, and Newfield. Okay. Oh, any question? Okay, try. Okay. So then let's go to the next topic. Wow, very fast today, yeah. So, is there any question about debugging, GUI? No problem. Sure, you can do it. I mean, okay. So let's go to Numpy. Numpy. Okay. So learning Numpy. So Numpy is one of the not standard Python outside. So you need to install, right? But I think if you are using Anaconda, so Numpy is already inside. Numpy and Panda is already inside. Why? Because Numpy and Panda is apparently well used, yeah, often used for many different reasons. Yeah? So let's go back. Let's go there. Okay. Okay. Numpy is a package for scientific computing, yeah, using Python. So you can have what is called ND array, n-dimensional array. So this is the one that make Python become similar to MATLAB or Fortran. Okay, so first, of course, to do that you need to have import NumPy as empty. I create a new Jupyter notebook. Okay, import. Okay, try. If this does not work, mean you did not install. Okay. Okay. So now you can you can create a NumPy list. Okay, using what is called arrays. Okay, so I will put here. So I will put A here. Okay, A is an array, a one-dimensional array, kind of vector, right? So of what is this? Arrays of 5. That means 0, 1, 2, 3, 4, 5. Hey, don't forget this A. Okay, is a NumPy in the array type. Okay, it's not a list. It's not the same. Okay, it's an object. Okay. So and then you can put the shape. What is shape? Shape is the size. Okay. So that's A dot shape. Right. Oh, there. Oh, 5. Okay, what is that? Oh yes, there is 5 elements inside. Okay, so shape means the size, yeah, of the array. Now, using NumPy, you can reshape. Wow, very nice. Okay, so let's do this first. Okay, so that you can see. I create a range from 10 to 32 and 3. What's that mean? Okay, it start from 10, increase 3, okay, up to 32, yeah, before 32. Is it clear? Okay, so let's name this B. Okay, so right, so if you put B here, you get exactly that. Right. Okay, yeah, you get B, right? So now using B, how many? What is the shape of B? B shape. B shape 8, right? So I can create a matrix out of one array. So if 8, then you will have 2 by 4 or 4 by 2, right? Okay, so then we can have reshape 2 by 4. Okay, so let's do that. So I have B, okay, dot reshape. Oh, the element is exactly the same, right? I can now create a matrix. Very easy to make a matrix in Numpy, yeah, right? Okay, so how about if 8 by 2, 4 by 2? Oh, super. Huh? Can you make it? You see, right? Okay. Uh, uh, Same thing here. So this is just. Oh, now I want to see the shape. Okay. So let's call this C. Okay. So C. Right. This is C. Okay. Now I want to see the shape of C. Oh, 4, 2. Exactly what you put here. Clear, clear. Okay, so another way is instead of arrays, we can use linspace. Okay, so similar to arrays. However, the third argument of the element is rather than the step. Yeah, it's the number of elements. It's not the step. Yeah, in arrays is the start and then the step to increase, right? In line space, the start, the end, and then the number of elements. Okay, so let's try that. So you have a 1 start, and then 23 is the end, and then 12. Oh, okay, 12 elements. You can see what is the shape. I want to see the shape only. I don't want to know the result. Okay, 12 elements, right? Of course, that is the Numpy. Clear? Yes. Or what happens if instead of 12, I make it 13? Well, let's try. Oh, it will equal space, yeah, divide it. Yeah? Okay. So now you can see lin space is linear space, meaning you can just divide between 1 to 23. Okay. What is the you divide equally? Clear, clear? Of course, with that you can reshape again. Same thing. So if you want to create a zero matrix, you just name it NP zeros. Okay. The same. Okay. NP 034, you get 0, 0, 0. So 3 is the number of rows. Okay. 4 is the number of columns. Be careful, yeah. Sometimes the common mistake is this is one number. So without this one is incorrect. Okay, this is incorrect. Okay. So you need to put it the shape. Yeah, you need to put the shape. The shape is 2. So you need to put it this way. Clear? Clear, clear. And then 1, of course, matrix or vector of 1, the same thing. Yeah? So instead of, so you can put this way. So there. Right. So if you want to make it integer, okay, you just type integer. Yeah? So the same thing here. instead of this, you can put in. Okay. Then instead of floating point, now become integer number. Same thing with that zeros here. Right? So you can just put in. Okay. Now become 0. It's not floating point. Clear? Okay. This is what you, if you want to make games, right? You create random number, right? So you just put random. Okay, random number. Okay, just NP random, random. Yeah. So and then the shape. Of course, it's random, so it will not be, your result will not be the same as mine. Right? So if you want to do a random integer, okay, so you just use this, okay, random integer. Okay, when you run again, it will give you different result. See? Oh, it's random integer finish. If you want, this is the nice thing. If you want to make that random integer, okay, let me do this, yeah. So I will call this R as random integer, right? Okay, so this is the one, R. Okay, let me run again. R still the same. Okay, now I can do like this. R, okay, larger than 5. Look, I can do mathematics. Okay, in Python, I can get that. Cool, right? Directly, okay, instead of doing loop, okay, without NumPy, what you will do looping, right? Look for each row, look for each column, isn't it? Huh? But with NumPy, you don't need to, huh? All you need to do is just do the actual arithmetic, okay, as if this is a number. Huh? This matrix, yeah, automatically it will run based on that function that you create. Cool, right? And let's do what is called masking, yeah? Filtering. Okay, so remember the R a while ago. Okay, so I will keep name this one. This is my mass equal. Okay, I will write here mass. Right, this one, right? This is my mass. So what I will do like this: R of mass. Okay, there. Oh, sorry, I need to do it. Oh, sorry. Where is my R? My R is okay. Oh yeah, it will create the array. Okay. R of the mass here. It will produce the array. What is this array? Huh? The one that is true. Okay. The one that is true. This is 7878. Right? The one that is true. Yeah. So this is another way. So I create this, I just copy this, yeah. G. Okay. Suppose you have this array. Okay, this array. I put it here. Okay. This is an array, right? And then what is this? What is the type of this? is a list, right? So let me keep name. So k equal this one, right? This is k, and then I want to get the type of k, right? Oh, k is a list, right? So it's not NumPy. I want to translate that list into NumPy array. Can I? Yes. So you just NumPy array of that k. Yeah. So the same, right? But now become a NumPy array. So let's call this kk. Okay. So then you will okay. So that you will see that kk. Okay. And then what is the type of that kk? Is NumPy. Yeah. Okay, so by putting any list, yeah, if you want to change it into NumPy array, just name np dot array of that list. You see, yeah. So, oh, you can also change the data type, okay, inside. Yeah? Suppose that the array you can put. So you want to put it data type is complex number. Okay. NumPy can do complex number. Okay. So here I put it as complex. There, it suddenly become complex number. Right. Okay. So cool. Right. Okay. So of course, okay, let's do this. This is now I'm dealing with three-dimensional array. Usually you have a matrix, it's two dimension, right? Array is just one dimension usually, and then two dimension. Now let's do a three dimension. So to do that, I create this first. Okay, so let's deal with three dimension. Okay, so I have a number between 0 to 29. Okay, let's keep name, for example, A. Okay, so I will keep name this one. A equal this. Okay, and then now I want to create three-dimensional array. Remember, a while ago what I did is reshape, right? So I do a reshape. Okay. A while ago what I reshape is only two number of rows, number of column, right? But this time I will make it number of tile. Okay, so there. Okay, so 2 by 3, right? 2 by 3 here. Each of the tile is 2 by 3, but what? I have the next tile. So three dimensions. Of course, you can create any dimension in NumPy. You can have 4 dimension, 5 dimension, and so on. It can be very complex. So one dimension is one just list. Okay. Second dimension, you can see the second list here, right? And then if you want 3 dimension, okay, just additional one more list. As simple as that. So it's a list inside a list inside a list. Is it clear?
Sir,
Yes, go.
how does the three-dimensional work? Like if two-dimensional is like rows and column, right? But
Right.
what about the dimension?
Okay. So this is dimension. This is dimension 1. This is the first dimension, right? And this is the second dimension. It's kind of card. Okay. One card is 2 dimension like this, right? And then this is like the card behind that. So it become 3 dimension. Okay. How about 4 dimension? Wow. Maybe you can create a block. Okay. One block consists of one face. Okay. So say for example this kind of paper. Can you see? Okay, this is 2 dimension, right? Okay, and then if you have many of this paper inside, so each line of this is basically one matrix, right? And this becomes 3 dimension. Now if you have many of this paper, okay, that becomes 4 dimension, and so on. Clear, yeah? Okay, some said, wow, 4-dimensional PA. Well, look, in mathematics, you can have an infinite number of dimensions, not just 4. Okay. Do I answer your question, Matthew?
Yes, sir. Thank you, sir.
Thank you. So, what do you think? NumPy is useful or not? So this is I put into diagram. Okay. So this is the position of dimension 2, dimension 1, and dimension 1, dimension 0, dimension 1, and dimension 2. Yeah. So I put it that way. Okay. Next is to do what is called selection. Yeah. Selection. So we have what is called colon notation. So this is originally in MATLAB. Okay, Python, the maker of this NumPy is copying that idea of colon notation. Yeah? So the colon notation is something like this: start, colon, end, colon, step. Okay, the start represents inclusive, okay, while the end is exclusive. Don't forget. Okay, and then if the start is omitted, the default is 0. Yeah? If the end is omitted, the default is the end of the array. If the step is omitted, the default is 1. So look at this. A is NP arranged 10, 15. What does that mean? Start is 10, end is 15, right? That will go to from 10, 11, 12, 14, 13, 14. 15 is not included because end is exclusive. Clear? Okay. So then you said, okay, A2. What does A2 mean? This is A0, A1, A2, so 12. Okay. Now, you can also say, look, I have A1 to 4. What's that mean? That means I will get from 1, this is A1, A2, A3, right? 4 is exclusive, so not included. Clear now? Huh? I can get some portion of the array or the matrix simply by using colon notation like this. Very, very nice, right? Oh, how about this one? I just colon 4. What's that mean? The first one is 0, right? And then colon 4. 4 is the end. Okay? Remember, end is exclusive. So, yes, 0 to 4. Yeah. Okay, exactly. So that's the exam question. How do you know? Okay. So, how about this? A colon 4 2. What's that mean? Okay, A is like this. Yeah? So colon 4 2, yeah, until the start is 0, right? And then up to the element number 4, but 4 is exclusive, and then the step is 2, right? So you have 10 and then directly 12. Okay? 14 is not included. Why? Because the end is exclusive. Okay? Oh, this is nice. How about this? This means all. Okay? So, this is exactly the same as in MATLAB. Yeah? A little bit minor change. How about in 2D? Okay, let's try this. Okay, let's create a matrix of natural number. Last time we create matrix of natural number with looping, right? In NP, you don't need to loop, okay? What you need to do is just one line of code, okay? Sorry. Oh, I got that. Wow. Cool, right? Last time you need to loop, right? You don't need to loop. Using Numpy, okay? You just create a range of 12 numbers and then you reshape it, right? In fact, you can reshape whatever you want. You can shape 2, 6, 6, 2, and so on. It's up to you, right? Okay. Hey, why I need to add 1 in here? What happens if I don't add 1? It will start from 0. Yeah, let's try so that you will see. It will start from 0. Okay. If you want to start from 1, so of course you need to add from 1. Clear. Okay, good, yeah. So now, because it's a matrix, okay, you need to have row and column, yeah. So now I get the portion of that matrix. I want to get that portion of that matrix from 0 to 2 and then 0 to 2. Where is that? Oh, I can slice some portion of it, right? Oh, what is that? 1, 2, 4, 5. Yeah, this part here, okay, in the top left. Okay, only 2 elements. Yes, because 2 is the n is exclusive. Don't forget that. Okay, the start is inclusive, the end is exclusive. Okay. How about this one? What is the meaning of this? Start from element 2 up to the end. Up to the end. Okay. So you will get 9 and 12. Where is 9 and 12? This one. Yeah? The last, the bottom right. Right. So elements start from 0. So 0, 1, 2. Right. So start from element 2 to the end. Okay. Is this clear or not? Yes. Easy, right? Oh, now I create something else here. So what is this? Okay, let me write A first so that you can see. Okay, and then I will write here. So what is this? Oh, I want to get the first row, right? That is row 0, right? And then the third row, right? And then the column will be from 1 to 3. 3 is exclusive. Okay? Can you see that or not? So the first row is 1, right? And then the third row, right? And then the first column, okay, this one, right? And then the up to, yeah? This one is column, right? So up to the second column. Yeah? So this is 0, 1, 2. So 3 is not included. Anyway, there is no 3 in this case. So that's easier to see. Right? Is this clear or confusing? Clear. Very good. Okay. Super cool. So now if you want to get not column notation, but you want to get element one by one, and you want to rearrange your matrix, yeah? So you can get that. Yeah? So this will create. Okay, let me write A again so that you can see the A. Okay, and I get that. Okay, what is this? I got 3 elements. okay, 3 elements, okay, 0, 0, 3, 2, and then 2, 1. Yeah? This is the row, this is the column. Okay, so that's exactly what you get, right? Clear, yeah? So can you see the difference between comma and colon? Comma means the actual element. Yeah? Colon is the range of the element. Okay, now if you want to, you can do from 1 dimension to 2 dimension, right? Using reshape, right? Okay, but how about if I want from 2 dimension come back to 1 dimension? Yes, you say, okay, let's do that. Yeah, this is A a while ago, right? This is A. What happened if we do reshape? Okay, so A reshape, instead of uh, 4 by 3, now I reshape it to 12 by 1. Can I? Oh, sorry. Yes, you can. Right? But there's a problem. What is the problem? It's still 2 dimension, this one. Okay? See, you see? 2 dimension. Double list. That means 2 dimension. The same thing here. If I have 1, 12, right? Okay? Again, this is still 2 dimension. Can you see that? Right? So now I want to change this into 1 dimension, not 2 dimension. If I have 3 dimension, I want to do it lower dimension. How to do that? So that exactly this function is about. Yeah, refer. Okay. So now you can do A. Okay, refer. Now you remove the dimension, you put it all together into 1 dimension. Is this clear? Yes, yes, yes. Question? No question? Of course, if you want to put back, you can use just reshape. Now, okay, I create A here. Okay, that A is already there, right? A shape is, what is this? 4 by 3, right? 4 rows and then 3 columns, okay? Let me create another one, B. Okay, let make me B is NP1. Okay. I want to create B. Okay, so B equal 3 rows. No, should be the same. So 4 rows, 3 columns, or maybe a 5 rows, so that you will see the difference. Okay, B is 5 rows, 3 columns. Can I combine, okay, A and B in one stack? Okay, so in that case, we call this 8 stack. Okay, so 8 stack. You can see, oops, what happened? We have different size. What is the size? Oh, let me check. A shape 4-3, B shape. Yeah. Okay, maybe not horizontal stack, but vertical stack I can do, right? Okay, so in that case I can do a vertical stack, so that up and down, right? Because the same number of columns, yeah. Okay, you cannot do a horizontal stack because they have different number of rows. here I can create a v stack. You see, this is 1 to 12 a while ago, and then you can add. So this is matrix concatenation. Yeah? Matrix concatenation. So next time when you learn about linear algebra, you need to do matrix concatenation. You can do it in Numpy, right? Okay. So when you go to the next class of linear algebra, you are very confident because you already have this code, yeah? Okay. So how about, let's create a new one, okay? Let's create a matrix C. So A, what is the size of A a while ago? 4, 3, right? Let's create a matrix C which is equal to NP zeros, okay, of what? Let's make it horizontal stack. So that means the number of row must be the same as A. The number of row of A is 4, right? So I will put 4, and then the number of column is up to me. So I will put 6. Okay, so C will become like this, right? So then what you will do, you can stack them. Yeah? You can do the stacking. So the same thing as before, yeah. Where is the stack? Oh, here. So now I will do A and C, but instead of horizontal stack, now instead of vertical stack, I will do horizontal stack. Yeah. So there I got it. Okay. Oh, if you want to do a Gauss Jordan, you can also do like this. Yeah, similar. Okay. So up to here, is there any question? Oh. So you can join, yeah, the matrix. Yeah? Of course, you can also do a column stack, row stack. It's the same thing. Yeah. So next meeting we continue with the splitting matrix. Yeah. And so on. So any questions so far? So today, what did you learn? You learn about GUI, yeah, number 1, yeah, and then unit test, yeah, and then NumPy. Okay. So next meeting we discuss NumPy a little bit, pandas, and then you do data analysis using Python, yeah, so that you can use Python forever, not just use for this class, okay, for any other class as well. Yeah. Okay, very good. That's the goal.